Hello students, in this module we will be learning measurement of central tendency of data using median and mode. Let's focus on median first. For calculating median of the given data we have a formula, that is L plus bracket n upon 2 minus CF upon F into H. Now remember, while calculating the median of the given data, the class interval of the data should be continuous. Now let's understand the different terms in the formula of median. Let's talk about L, that is lower limit of median class. N represents the total frequency. CF represents the cumulative frequency of class preceding the median class. F is the frequency of median class. H is width of the class. For calculating median, we have different steps. Let's learn the steps first. Step number 1 state, find the value of total frequency upon 2 and denote it by x. Then we need to search the cumulative frequency column. In that column, we need to search for the cumulative frequency whose value is greater than or equal to x. The corresponding interval of that cumulative frequency will be median class. Now to understand how to calculate median, let's consider a sum. The sum states the following table gives the distribution of lifetime of 400 neon lamps. As the data is given in the table, we need to calculate the median life of a lamp. Now before calculating the median lamp, we need to ensure that the class intervals are continuous. As we can see, the class interval is continuous. We will prepare a table having 3 columns stating class, frequency and cumulative frequency. As we can see, lifetime is considered as class interval and number of bulbs are considered as frequency. Then if you remember, CF in median class was cumulative frequency of less than type, and we know that for calculating cumulative frequency of less than type, we start from the top of the frequency column. That is, we will consider 14 as it is. Then 14 is added to 56. We get 70 and we write 70 beneath 14. Then 70 is added to 60. We get 130. We write 130 below 70. Then 130 is added to 86, and subsequently we keep on adding the next frequency to get the next cumulative frequency, and we reach the end, that is the last cumulative frequency of the column, that is 352 plus 48 will give us 400. As we can see, the cumulative frequency is in ascending order. This represents the less than type cumulative frequency. After that, for calculating the median, we need to find the different terms. First, we will be calculating x, and for x, we will be calculating n upon 2. Therefore, n upon 2, that is 400 upon 2, will give me 200. That is x. Now, we will be looking for the value in the cumulative frequency which is greater than or equal to 200. As we can see, the value in cumulative frequency column, that is 216, is greater than 200, and the corresponding class interval is considered as median class. From there, the median class that we consider is 3000 to 3500. Now, as we know the median class, now there will be different terms that we are going to note down. For example, for median, the first thing that we will be talking about is median class. After that, we will be talking about CF, that is cumulative frequency of the class interval preceding the median class. As we can see, median class is 3000 to 3500. Then the class interval preceding the median class is 2500 to 3000. The corresponding cumulative frequency will be CF. So we mark CF as 130. Now we know N upon 2, we know F, we know CF, we will mark L. L is the lower limit of median class, which is 3000. We know L. Once we get L, we will be writing H. H is class width, that is 2000 minus 1500, that is nothing but 500. We know class width, we know L, we know F, that is frequency of the median class, that is 86. We mention 86 and then we mention CF as 130, that is cumulative frequency of the preceding median class. Once we get all these values, we will use the formula, that is median is equal to L plus bracket N upon 2 minus CF upon F into H. We substitute the respective values and we write 3000 plus bracket N upon 2, that is 200, minus CF, that is 130, upon F, that is 86, into H, that is 500. We simplify it, we get 3000 plus 175 upon 43 will be 406 point, is 3406.98 hours. With this, we know how to calculate median of any given data. After this, let's understand how to calculate mode. For calculating mode, we have a formula, that is L plus bracket F1 minus F0 upon 2F1 minus F0 minus F2 bracket close into H. As the formula is complex, we need to learn the different terms in this formula. But before learning the different terms, we need to ensure while calculating mode, the class interval should be continuous. Now moving ahead with understanding the different terms in mode, we will once again write the formula and then we find L, that is lower limit of the model class. F1 is maximum frequency. F0 is frequency of class preceding the model class. F2 is frequency of the class succeeding the model class. H is equal to width of the class, that is class width. Now we need to understand the model class is nothing but the class having maximum frequency. Now to understand mode in a proper way, let's consider one sum. The sum states the following data gives the information on the observed lifetimes of 225 electrical components. The data are lifetime and frequency. Now from this we need to calculate the modal lifetime of the components. For that we will be using the formula that we have learned. But before that we need to prepare a table. Now from that table, if we consider, we need class interval and we need frequency. From there, we will be taking the lifetime as class intervals and we will be taking frequency as 10, 35, 52, 61, 38 and 29. Now from these, we know that the maximum frequency will give us the model class. After getting class interval and frequency, we will identify the maximum frequency, which is 61, and the corresponding class interval is the model class. Then we mark 61 as F1. F0 is the frequency of the class interval preceding the model class and F2 is marked as the frequency of the class interval succeeding the model class. We know F0, we know F1, we know F2. Now we will be identifying L, that is lower limit of the model class, which is 60. We know H, that is 20, which is the class width. And We also know F0, F2, and then we can use the formula to calculate mode, that is L plus bracket F1 minus F0 upon 2F1 minus F0 minus F2 bracket close into H. We substitute the respective values, that is 60 plus bracket open 61 minus 52 upon 2 times 61 minus 52 minus 38 into 20. From these values we simplify, we get 60 plus, in numerator we will get 9 upon, we get 122 minus 90 into 20. We simplify it further, that is 60 plus 180 upon 32. We cancel it out, we get 5.625. We add it to 60, we get 65.625. That is the model lifetime of the electrical components is 65.625 hours. With this, we have learned how to calculate the measurement of central tendency of the given data. Thank you.